Teach me how to factor. That's what we're going to talk about today. Factoring. Let's go to work. Teach me how to factor. Factoring a quadratic is the process of manipulating a quadratic in standard form in order to change it to intercept form. This allows us to see the roots, solutions, x-intercepts, zeros quickly and easily. All right. We started off today by just doing quizzes on distribution. Yes? Factoring is the opposite of that. It's opposite of distribution. Well, distribution is really multiplication, right? Hey, factoring is really division. Factoring is really dividing. We're going to take this quadratic and we're going to divide it up into smaller parts. And the really cool thing about it is when you do divide it, when you factor it, you can see the zeros or the x-intercepts, okay? Remember what we just spent a whole bunch of time on graphing, yeah? I mean, a lot. There were three important parts of each graph that we were looking for. The vertex and the two roots or solutions, yes? Well, this, by factoring a quadratic and putting it into factored form or intercept form, we can see the roots, solutions, zeros, or x-intercepts just by looking at it. We like it a lot when we can just look at it and see the answer, right? Okay. But this is a process. Now, most people really, really struggle with factoring, okay? But most people don't have me as their teacher. I'm going to teach you a process. Honest to goodness, when I learned this, you know how we learned it? We used the guess and check method. In other words, you guessed what the answer was, and you checked to see if it was right, and if it didn't work, you guessed again, and you checked it, and you guessed, and you checked, until you found it. That was stupid.
That wouldn't work on a quiz.
Yeah, it just took forever. I'm going to teach you a process that works, and it's tried and true, okay? Factoring is really hard. But I hope at the end of the day you think, man, this is easy. And when you can hit your Staples easy button. All right, let's get into the process. Since you guys already have all of that written down, what is the process? Well, here it is. The process is, the very first thing we're going to look for is a GCF. Look for a GCF. That's something everyone should know. Okay. What is a GCF? Greatest common factor. Okay. Let's look at these two problems over here on the right. Let's start by just looking at the top one. Is there a GCF in that? Is there any numbers or variables that can go into both of those terms? What? 2 can go in. Is there anything else? Well, one will never count. 1 always goes in, but 1 never counts because he's special. He goes into everything, right? So we don't count 1. But how about an X? Isn't there an X in both of those? Yeah. So I could also pull out an X. So that's a 2 and an X are common in both of those, right? So you're thinking to yourself, now 2x times what gets me 2x squared? Or 2x squared divided by 2x. There's 2 ways to think of it. I think the easiest way to do it is just think to yourself, 2x times what gets me 2x squared? Times x. Now, 2x times what gets me 4x? Yeah, times 2. And there I just factored out 2x. That was a GCF, yes? So look at the second one here. Is there a greatest common factor? Is there a number that goes into all of that? Yeah, number 2. 2 times what gets me 2x squared? 2 times x squared gets me 2x squared, right? 2x times what gets me 6x? Yeah, 3x. And 2x times what gets me 4? 2. I factored out my GCF, or I found my greatest common factor, and I pulled it out. Now, that's the very first thing we want to do. We always want to do it because it makes our life easier. It's still possible to factor these things if you don't take it out to GCF, but it's terribly, terribly difficult. Are you with me? So first thing we're going to do is look for a GCF. That's something everyone should know. Now, once we've found our GCF and we've factored it out, then we're going to look and we're going to say, hey, is there a leading coefficient? Again, not looking for 1 because 1's always there, right? But is there a leading coefficient other than 1? And then your answer determines what we're going to do. If there is a leading coefficient, we say yes. Later this week, I'm going to teach you something called the box method. Now, the box method works even if you don't have a leading coefficient. It just creates a little bit more work. Okay, and come on, I'm lazy, just like you. I'm all about doing it the quickest and most efficient way, right? And that's the only reason why I teach you 2 different methods. Some teachers will only teach only the box method. That's okay. So what if we say no? No, there is no leading coefficient. Then we're going to split in signs. Once we split in signs, we'll list the factors of our constant. Once we have those factors of our constant, we'll be able to fill in and finish up our factoring. It's really not that long of a process. Okay? You ready to try it? All right, let's look at one. Let's say I have x squared plus 3x plus 2. Let's go through the process. First, is there a GCF? No. Is there a leading coefficient? No. So I'm going to split in signs. Means I'm going to put down 2 sets of parentheses. I put an x in each. Signs, when it comes to signs, I always start off by looking at this last sign. Always look at the last sign. Always look at the, a little bit louder. Always look at the last sign. Now, this right here, that's your cheat sheet. If the sign is a positive, you're going to use the same signs. If your sign is negative, your signs will be opposite. Are you with me? Okay. So as I look at this, I see that it's a plus. That tells me they're going to be the same. I don't know if they're both going to be plus or both minus yet, but I know they're going to be the same. Now, once I know they're going to be the same, I look at the middle one. And the middle one tells me if they're both positive or negative. In this case, they're both positive. Everybody understand what I mean by split and signs? That was really easy, yes? Okay. The last thing we do is list the factors of the constant. Well, my constant is 2. What are the factors of 2? 1 and 2. 1 times 2 is 2. So those are the factors, right? Do those 2 factors add together to get me the number in the middle? Yes. 1 and 2. I put them in those 2 places. Boom. I just factored that quadratic. If you follow the steps, this process will be simple for you. Okay? Let's try it again. First thing, is there a GCF? No. Is there a leading coefficient? No. So, wait a minute, you just said no, there's no leading coefficient, and I'm saying so. Split in signs, thank you, everybody. So, split in signs. I'm going to put 2 sets of parentheses, put an x in each. The signs are going to be the same, and they're both going to be positive. I really want you to say first, same or opposite, and then tell me what they are. This is cool. Okay, now what? List the factors of 12. Well, 1 times 12 is 12. 2 times 6 is 12. 3 times 4 is 12. And that's it, right? Okay. So do any of those come together to get me a 7? 3 and 4. So those go in. Does it matter if I put the 3 there and the 4 there? Does it matter? Can I put them in the opposite spots? In this case, it doesn't matter. Okay? Yes, sir.
What do you mean in this case?
The signs were the same. So since the signs are the same, it really doesn't matter where they go.
No, but if they're opposite.
If they're opposite, it's going to matter.
Yeah, because then you have a completely different sign.
Yeah, and I'll tell you about that one in a moment. Okay. Now, I want to talk about this list of factors here for a second. Okay. Now, I do this in a specific order and for a reason. Now, stay with me here. Let's say we had the constant of 24. Okay. Let's just say I had 24 was my constant, and I need to list all the factors of 24. This is how I do it. I always start with 1, because 1's always a factor, right? And in this case, it would be 1 times 24, right? And then I work my way down the numbers. 1, 2. Does 2 go into 24? Yes, 2 goes in 12 times. Now, I knew that 2 goes in because it's even. And 2 goes into every even number, right? There are divisibility tests that I'm going to share with you later about how to remember which numbers go into which. And I'll share those with you later. But here's what I want you to understand is by doing this process, do you know that I don't have to check any number between 12 and 24? I'm not going to have to check any of them. Matter of fact, when I do this process, as my numbers come together, I save myself work. For example, I checked 1, I checked 2. Does 3 go into 24? Yes. How many times? 8. Does 4 go into 24? Yes. How many times? The only number that's left between 4 and 6 is 5. Does 5 go into 24? No. So I'm done. See how my list on the top and the bottom came together? And that's the reason I go in order like that. And you'll see me do it repeatedly. Even in other examples that I'm doing on videos and stuff, you're going to see me list them in that way every single time. It saves myself work. And I'm sharing that gift with you. Can I get an amen?
Amen.
Okay. Let's try this one, please. I'm going to let you try the first one on your own. Go. Is there a GCF? No. Is there a leading coefficient? No. So, split the signs. Put an X in each. Signs are opposite. So a plus and a minus. List the factors of 10. 1 and 10, 2 and 5. Do any of those come together with opposite signs to get me a 2? No. Oh no. Whatever will I do? This is what we called not factorable. It happens. It happens from time to time. Now, this doesn't mean there are no solutions or anything like that. All this means when it's not factorable is it's going to cross the x-axis at decimals or fractions, or it might not cross at all. Remember how we have some that float, right, and don't cross the x-axis? It could be one of those, or it could just cross at a non-whole number. Now, there's still ways to solve this, and we're not worried about it today. It's called the quadratic formula, okay? We'll use that later, all right? But I just want you to know that it's okay if you trust this process and you get this list. Is that all the numbers that come together to get me a 10? I didn't miss any, did I? Nope, that's all of them. So since that's a complete list, this is just not factorable. Understand? Let's try another one. Is there a GCF? No. Hey, hint. If there's not a leading coefficient, there can't be, or there won't be most likely won't be a GCF. Cool. If there's no leading coefficient, most of the time there's not a GCF. Just FYI. All right, so no GCF. Is there a leading coefficient? No. So split in signs. X in each. Signs are same, both negative. Negative and a negative. Factors of 9. 1 times 9, 3 times 3. Any of those come together to give me a 6? 3 and 3. Does it matter where they go? No, because they're exactly the same. Cool?
And that's it. How would they both be negative?
How would they both be negative?
Like, if you're having lines.
Like when you have.
Because when you're multiplying, we can FOIL to check our work. This is one thing that's cool. X times X is squared. X times negative 3 is a negative 3X. Negative 3 times X is a negative 3X. Negative 3 times a negative 3 is a positive 9. Combine those two like terms. X squared minus 6X plus 9. Cool. Yeah. Good question. I think I had one more. Oh, yeah, there we go. 2 more. Let's try this one, please. All right. Is there a GCF? No. Is there a leading coefficient? So split in signs. Put an X in each. Signs are opposite, so put a plus and a minus. List the factors of 35. Stay with me. Does 1 times 35? Does 2 go in? No, because it's not even. And 2's got to go into an even number. Matter of fact, I don't have to check any even numbers, do I? Because there's no even numbers that can go into an odd. Okay, that's cool. So I don't have to check 2. I don't have to check any evens. 3, does 3 go in? No. 4, I don't have to do 4. 5, does 5 go in? Yeah, 7 times. And the only number between 5 and 7 is 6. Wow. Do you see how I did my process again from 1, working my way down? Didn't that make my life a lot easier? Like, how many of you sat there for a second really thinking about all the factors of 35? Yeah, and that's okay. There's nothing wrong with that. But I'm just sharing with you, follow this process, it'll be a little bit easier. And you won't miss anything that way either. Okay. Do any of these come together with opposite signs to get me a 2?
No.
Wait,
Yeah.
not 5 and 7.
5 and 7. They have opposite signs, right?
Yeah.
Now, here's the thing. When the signs are opposite, the larger number of the 5 and the 7 is going to get the sign from the middle. The larger number gets the sign from the middle. This problem's not too bad if you study just a little. So the 7 goes with the negative and the 5 goes there. Cool? Can you handle it? Last one we're going to do together. Oh, I'm going to change this one. Hold up. There you go. Claim it. Give everybody one of these, please. Are you ready? Is there a GCF? No. Is there a leading coefficient? No. So, splitting signs. Put an X in each. Signs are opposite, so a plus and a minus. Factors of 6. 1 and 6, 2 and 3. Do any of those come together with opposite signs to get me a 5?
No, wait, yes. 6 minus 1.
6 minus 1 is 5.
I'm so confident.
Remember, your signs got to be opposite, right? We've already dealt with those signs, right? So it's got to be 1, 6. The larger number gets the sign from the middle. 6 and 1. Cool?
Yep.
Think you can handle it?
Absolutely.
All right. You have a Teach Me How to Factor worksheet there in front of you. Problems 1 through 4. All you got to do is take out the GCF. Okay? Yeah. And then 5 through 16, you're going to factor. I do want you to take a quick look. Take a quick look at these. Do you see any leading coefficients? None of them have a leading coefficient, do they? I would like you to put a star beside 10 and 15. 10 and 15. And I'm giving you a hint right here. Those are the only two that have a GCF. And I'm going to leave it at that. Okay. Have a great day.
Have a great day.
Are you on? What do we do about people?
So we